welcome back to the second part of the video on STA 314. Before I commence this, I will implore every one of us that is watching this video to please subscribe on my channel. That will help me to do more on this video. If you have not done so, please do that. Now, my fourth video will look at random variable. We consider discrete random variable, and I told you discrete random variable is divided into three. We have Bernoulli, binomial, and Poisson distribution. And in my fourth video, we look at the Bernoulli. We also look at binomial, and that is where we stop. Now, I want to continue from where we stop. Now, I see that if you look at the last problem I solved in that first video, I said it is easy for you to use statistical table to evaluate your probability than solving it manually. Even there are some cases that you don't even be able to use manual to solve the probability question. And because of that, for you to be able to apply the statistical table, then you need to understand the following property on the board. You know, I told you statistical table only recognize when your x is less than or equals to the a. That is what statistics, that is a cumulative table from 0 to where your x ends. And that is the first. If you look at Roman figure 1, I said if your x is at most a, it means your s has started from somewhere and it ends in what? In a. And that is why we have s is less than or equals to a. That is, s starts from a value that is less than a and it stops at a. That is why, and that is what your statistical table can check. And that is Roman figure 1. What if we now have s is greater than a, or s is at least a? It means if s is at least a, it implies s is greater than or equals to a, which can be expressed. Since the statistical table do not understand greater than or equals to, the only statement the statistical table understand is what? S is less than or equals to a. Then I need to express my s is greater than or equals to a in form of what? S is less than or equals to a, and that is equals to 1 minus probability of x less than or equals to a minus 1. It means you are going to remove minus 1 from your what? From your a, for you to be able to be in that point of greater than. The Roman figure 3 says s is exactly or equals to a. If you remember the last question I solved on the fourth video, that we said if you have s is equals to exact, you can apply the formula. You can also use the table, and it's also equivalent to probability of x less than or equals to a minus probability of x less than or equals to a minus 1, because you want to get the what? The exact value, and that is what you will use. Roman figure 1, 2, 3 is talking about one bound. What if you have two bounds, the upper bound and the lower bound? Then what are you going to have? If a is less than or equals to x and the same s is less than or equals to b, then it's the same thing of saying probability of x less than or equals to b minus probability of x less than or equals to a minus 1. Please watch out. If your upper bound is less than or equals to b, you leave it like that, because but a is less than or equals to x, you need to subtract 1 from this a. That is how you will get the probability. Now for Roman figure 5, if a is less than x less than or equals to b, look at it now. Your upper bound is still very okay. S is less than or equals to b. You put it like that. Minus, now your a now is less than x. We are not going to change it. It's just going to be minus probability of x less than or equals to a. If the lower bound is less than or equal, it does not have equality sign, then you leave it like that. Now look at Roman figure 6. If a is less than or equals to x less than or equals to b, firstly compare Roman figure 4 and 6. You see that when you have a less than or equals to x, what are you going to do? You are going to subtract 1 from what? From the lower bound. That is why you have a less than or equals to x. That's why you see minus s less than or equals to a minus 1. Then this b, this x is less than b, does not contain b, then we need to subtract 1 from b. That is why we have it to be probability of a less than or equals to x less than b is equal to probability of x less than or equals to b minus 1 minus probability of x less than or equals to a minus 1. And that is how to do with the probability. Lastly, when you have, if s is greater than a, there is difference between s is greater than or equals to a as Roman figure 2, but this one is strictly greater than a, and the same as saying 1 minus probability of x less than or equals to a. You will not subtract anything. Those are the properties of probability. 8 to showcase the properties of probability function. Now, the example is, it is assumed that 20% of the children in a locality are infected with cholera. Suppose that 11 children are selected at random. Let x equals to the number of children that are affected. Find this. Now, solution. What are we given? The first one is, we are given sources my p to be equals to 20%, and 20% is 0.2. We are given my n to be equals to 11. Then they ask us to find this. I've told you, when this type of question is given, the best approach is for you to use your table, statistical table. Then I will come out with my own statistical table now. This is my own statistical table. Then let's see how to apply it to the question. The first one, Roman figure 1, they ask us to get p of x less than or equals to 2. Normally, if you want to solve this question without the table, you know how to solve. It means you are going to get for what? S equals to 2, and s equals to 0, s equals to 1, and s equals to 2. You add it together. But for this, we can use our table. The table understand s is less than or equals to 2. What you just need to do is open your table, look at the first page there under cumulative binomial probability, binomial probability. Then the first thing you find is your n. My n here is 11. I will locate 11. This is 11. Then my s is now my c, which is what? 2. I will check 2. Then the sources, which is my p, is 0.2. Then I will check 2 under 0.2, and that easily gives me 0.617. 0.617. Now the Roman figure 2 now, this is just direct. The easiest thing is that you are still going to be checking under your n equals to 11. Now the second one we want to check is p is equal, x is equals to 4. As I told you, the probability distribution only understand s is less than or equals to something. S is less than or equals to 2. That is why I can easily check. But it does not understand s is equals to 4. Then remember, from the property I gave you, this s is equals to 4 can be written as probability of x less than or equals to 4 minus probability of x less than or equals to 3. That is what it's going to be for that. And we want to get the midpoint. Now, probability of x less than or equals to 4, I will still go to look at it. This is from 11. Then I will check my s, which is 4. S here will be c. Then I will check under 0.2. Then if you trace it, you will see that you are going to have 0.960. 0.960. This is 0.960 minus. Now I will also check under 3 now. The same thing under 3 now. Sorry, 0. This first one is 0.50. Sorry. Then the one under 3 is going to be 0.839. 0.839. Then if you use your calculator to confirm it, you are going to have 0.950 minus 0.839. Then the answer is 0.111. That is how to use it. If you have exact value, s is equals to, it's going to be the upper bound minus the lower bound. The upper bound will be your number, the lower bound will be subtract 1 from the number. That is how to get that. Now, the Roman figure 3. We want to find p is less than or equals to 4. P is less than or what? Equals to 4. And I've told you, this is the same as saying 1 minus p is probability of x less than or equals to 3. Now, what is that? We are going to have 1 minus, we have checked for probability of x less than or equals to 3, which is what? 0.839. Then at the end of the day, we are going to have what? 1 minus 0.839, which is equals to 0.161. That is Roman figure 4 now. We want to look at Roman figure 4. And Roman figure 4 is, we want to get probability of 3 less than or equals to x less than or equals to 10. And this can be expressed as probability of x less than or equals to 10 minus probability of x less than or equals to 2. And what is that? Still on the same probability table, I'm going to check probability of x less than or equals to, that is, I'm going to get to 10, trace to 0.02, which is 1.0. That will give me 1.00 minus probability of x equals to 2. Then I trace it to 2, which is what? 0.617. 0.617. 0.617. Then if I subtract it, I'm going to have 1 minus 0.617. Then I have 0.383 as my answer for question number 4. Question number 4. Now, number 5. Question 8. I jumped. This is question 7. Sorry. I think this is question 6. Sorry. Let me go back to question 4. I've not done question 4. Sorry. I will do it here. Question 4. We want to get probability of x greater than 7. And this is going to be what? 1 minus probability of x less than or equals to 7. And what is that? I'm going to check probability of x less than or equals to 7. Just trace to 7. And that one is what? 1.0 is still 1, yes, is 1, which is 1 minus 1. And this will give me 0. We can confirm it. This one will give me 0. It's going to give me 0. Now, why the other one? Probability of number 5, probability of x greater than 9. You also give me what? 1 minus probability of what? X less than or equals to 9. And probability of x less than or equals to 9 is also 1, which is also 1 minus 1, which is equals to 0. The same thing. Why lastly, I've done number 6. Now let me do the number 7, which is the last one there. Number figure 7. And what is that? We have probability of 2 less than or equals to x, probability of 2 less than x less than 4. And this will be equals to what? Probability of x less than or equals to 3 minus probability of x less than 2 or equals to 2. That is what this one will give us. And if I check my table, we have checked for probability of x less than or equals to 3 before, but let me still confirm it. Okay, next, probability of x less than or equals to 3 is 0.389 minus probability of x less than or equals to 2 is 0.617. 0.617. And at the end of the day, this will give me what? 0.839 minus 0.617. And this will give me 0.222. And that is the solution to the whole question. It's just very simple and easy. Just understand how the probability cumulative distribution change, then you'll be able to get your value. The last part of discrete probability or discrete random variable is what we know as Poisson distribution. And when it talks about Poisson distribution, it's just like your binomial distribution. But the difference is Poisson distribution require time of events occurring. Whenever you are given a question that involve time or day or any time of occurring, then use Poisson. An example is if an accident happen now in a particular day, you can say it's an example of Poisson distribution. Let's say yesterday, you just say yesterday by 2 p.m. an accident occurred on terminal bridge. Is an example of what? Poisson distribution. Now just take note that Poisson distribution require what? Time. Now let's look at the PDF for Poisson distribution, probability density function for Poisson distribution, and is defined as e raised to power of lambda over x factorial times what? Lambda. That is the Poisson distribution. E raised to power lambda, sorry, this is lambda x, yes, lambda raised to power x, e raised to power lambda divided by what? X factorial. That is the Poisson PDF or distribution. Now this is minus lambda. Now where my lambda is the expectation of the what? Of the distribution, and we know that expectation is same as what? Your expectation is your mean. It means the expectation of Poisson distribution is what? Is equals to the lambda. Also, Poisson distribution can be expressed in this form: P lambda, in which this lambda denotes the expectation of the Poisson distribution. Now with this all parameter, then we can look at how to apply it to solve question. As I said, your x still range from 0, 1, continue, while your lambda is the expectation or the incident rate that happened. Your e is a constant. It's a constant that has a value. You can press down directly from your calculator. Now let's look at example to showcase this. Example. I have with me here. Suppose S is a Poisson distribution, Poisson random variable with parameter x expressed as p naught 4. Sometimes you will see this p. Where is the p? There will be p naught. It's the same as p naught 4. The question now say compute. Number figure 1. We have p of x less than or equals to 4. Number figure 2. P of x less than 5. Number figure 3. P of x greater than 6. Okay. Number figure 4. P of x equals to 3. Number figure 5. P of x greater than 5 or equals to 5. Number figure 6. P of 2 less than or equals to x less than or equals to 5. Number figure 7. P of 2 less than or equals to x less than or equals to 5. Then if you pick your statistical table, you are going to notice that here we are dealing with Poisson. Then if you check your table, your Poisson distribution is the one that follow your binomial distribution, and Poisson distribution is on table 2. You will see it clearly, page 8. That is your Poisson distribution. And if you look at the distribution table, it's totally different from binomial, because the only parameter needed there, they are just two: your value of lambda and your values of x. That is just the parameter needed. Now let's pick them one after the other. My lambda, if I compare solution, if I compare S P naught lambda, you will see that your lambda is now equals to what? Is equals to 4. If my lambda is equals to 4, then I will trace where my lambda is equals to 4 from the point. 4 means 4.0. If you look at this first page, then it starts from 0.1, then this is 2.0. Then I open to the next page. If I can see 4, yes, this is okay. 4.0, we have 4.0 here. That is the value of my lambda. You see it, lambda is the horizontal values here. You see it from here, lambda, which is then at your expectation. Then you see that you are going to see your 0.4 here. Now the first one you want to get, you only need the value of lambda and the value of x. The value of lambda is horizontal, while the value of x are what? Vertical. Now pick the first one. P, probability of x less than or equals to 4. As I said, statistical table only recognize x less than or equals to. Now if I want to check x less than or equals to 4, then I will just come when I have 4.0, then I trace it to 4. And what is the value? Is 0.629. It means this is equals to what? 0.629. That is the Roman figure 1. Now for Roman figure 2. For Roman figure 2, the value here is going to be what? Is going to be probability of x less than 5. It's going to be, I can check x less than 5 from the table, and this is equivalent to 1 minus probability of x less than or equals to 4, which is very easy. I've checked x less than or equals to 4, then this will just give you what? 1 minus 0.629, which is going to say this is what? 0.371. That is the second question. You see that it's very simple, because when you have x is less than 5, you are going to subtract 1 from the value, and that is how to get this. Now the third one, let me clean this. Roman figure 3. Probability of x greater than 6. And what is that? This is equivalent to 1 minus probability of x less than or equals to what? 6. Probability of x less than or equals to 6. And to check this, we are going to have 1 minus, now the same point 4, then trace it to 6. I'm going to have what? This is 0.889. 0.889. Then this will give me 1 minus 0. This is 0.111. If I'm correct, you can check. 121. Sorry, this is 121. 121. That is Roman figure 3. Then Roman figure 4. Roman figure 4, I have P is S is equals to 3. And I've told you cannot check this. It's going to be probability of what? X less than or equals to 3 minus probability of x less than or equals to 2. That is how to get 3 from our previous example. And what is this? Probability of x less than or equals to 3. Have you done that? Let's check. I'm going to go to 3. If you look at 3, 3 will give me 0.433. 0.433 minus probability of x less than or equals to 2 is going to give me 0.238. And what is that? If I subtract this, I'm going to have 0. What is the difference? 2. Is it 2? No. Let me use my calculator so that I will get the accurate value. Now I'm going to have 0.433 minus 0.238. This is 0.195. 0.195. That is that. Now the next one is probability. That is number 5. Probability of what? S greater than or equals to 6. Greater than or equals to 5. And what is that? This is 1 minus probability of x less than or equals to 5. And what is that? 1 minus probability of x less than or equals to 5, you come to the same table, just trace it to where x is equals to 5, and what did I have there? 0.785. 0.785. Then if you subtract with your calculator, you are going to have, this is equals to 0. Let me subtract it so that I will not make mistake. 0.215. Now that is Roman figure 5. Roman figure 6 is also very simple. Probability of what? 2 less than or equals to x less than or equals to 5. And this one will be what? It will just be probability of x less than or equals to 5 minus probability of x less than or equals to 1. That is what this will give us. And what is that? Probability of x less than or equals to 5. We have checked, which is, look at it here, 0. There is an error. This is 4. This will be 4. Sorry. This Roman figure 5. When you have greater than or equals to 5, you subtract 1. This is not correct. Let me change this. When it is 0.4. When it is 0.4, it is 0.629. Sorry. And when you subtract it, I'll make the correction. 1 minus 0.629 is 0.371. Now, please look at the correction of Roman figure 5. Probability of x greater than or equals to 5 will be 1 minus probability of x less than or equals to 4. Then when you check 1 minus probability of x less than or equals to 4 is 0.629. Then when you subtract, you have this. Now, the Roman figure 5, we want to look at probability of 2 less than or equals to x less than or equals to 5, and that will be what? Probability of x less than or equals to 5 minus probability of x less than or equals to 1. We have checked probability of x less than or equals to 5 and it gives us 0.785. While probability of x less than or equals to 1 is going to give us 0.092. And if you press your calculator, that will give you 0.785 minus 0.092. And what is that? 0.693. 0.693. You get the answer for that. Lastly, let me solve the last question, which is probability of the 7th one, Roman figure 7. Probability of 2 less than or equals to x less than or equals to 5 is going to be, sorry, less than 5 is going to give me probability of x less than or equals to 4 minus probability of x less than or equals to 1. This is what it's going to give me. And what is probability of x less than or equals to 4? We have checked this before, but let me recheck again. Probability of x less than or equals to 4 is going to give me 0.629. 0.629 minus probability of x less than or equals to 1 is 0.092. Then if I press my calculator, I will add 0.629 minus 0.092, and that will give me 0.537. That is the solution to the question on Poisson distribution. Let us look at it. Just make sure you understand how the probability cumulative change. It is very, very important. If you familiarize yourself with it, then it's going to be very easy for you. Just make sure you get that. The next thing we want to look at now is how to approximate Poisson distribution to binomial distribution. Poisson distribution and binomial, they look alike, but the difference is Poisson is what? Take time of what? Occurrence into what? Into cognizant. Now, how do we approximate my Poisson to? It's just very simple. If you recall, if for binomial we have vi approximate to n comma p. Then for Poisson, you see that you have something like this, lambda. Now from this, you see that expectation of Bernoulli is what? NP. While expectation for binomial is lambda. Then if you compare the two, you will see that your lambda is always equals to what? NP. This is how to approximate. Your lambda is always equals to your what? Your NP. But how are you going to know? Either you are going to use Poisson or you are going to use, it depends on how the question look like. Let me just give you one example to explain or to illustrate the relationship, and that is, now let's look at example. I think this should be like example 10. In a manufacturing company, comma, the probability that one call is wrongly connected is 0.04 for a day, full stop. For a day, when 1,500 independent calls are connected, find the probability that 5 wrong connection where connection are made. Now if you look at this question, it looks like binomial distribution, but look at it now, because we have our P, we have our N, and we have our X. But this is not binomial distribution because a particular time is indicated, which is what? For a day. That is why I said it is very, very important. You need to look at the question. It looks like a binomial really talks about the number of occurrence or the number of trial. We will not take into cognizance the time duration. But this one take into cognizance time duration. Then it means this is an example of what? A binomial distribution that we want to approximate to what? To Poisson. And if you look at that, what we just need, our given N here is 1,500, and our given P is what? Is 0.04. Then if you want to solve this question, our X is equals to 5. If you want to solve this question, if you go and use binomial, you are wrong. You need to consider the question very well. We are going to use Poisson, and if you look at what is probability distribution, PDF of Poisson is what? Lambda raised to power x, e raised to power minus lambda divided by x factorial. I have all other parameters except for lambda. Then from the knowledge of approximation, you see that my lambda can also be expressed as what? NP, which is equals to what? 0.04 times 1,500. If you press your calculator, you are going to have 0.04 times 500 times 1,500 is going to give me 60. It means my lambda is what? My lambda is 60. Then if I substitute that, I'm going to have f of x equals 60 raised to power, my x is 5, e raised to power minus 60 divided by what? 5 factorial. If you press your calculator, e is what? If you look at it, is shift lib is going to give you e minus 60 is going to give you value. It gives you value, a very big value, times 60 raised to power of 5 is going to give me this, divided by, I'm going to get 5 factorial is divided by 5, the answer divided by 4, divided by 3, divided by 2, and at the end of the day you will see that I have 5.67 times 10 raised to power minus 20. It's a very, very small value, insignificant value of what? The approximation. This is where we are going to draw the cutting for discrete random variable. Please try as much as possible to look at it very well. Then in my next lecture, the video 3, we are going to look at continuous random variable. We are going to look at, please remember to subscribe and comment on the what? Comment box. Like the video, subscribe, comment. If there is anything you don't understand, put it on the comment chat, then we are going to react to that later. See you guys in our next video.